Hello everyone, my name is David. I'm a co-owner at D&A Computer Works. We're a small computer repair shop located in Pooler, Georgia, specializing in desktop and laptop repair with an emphasis on data recovery and e-waste recycling. About 5 years ago, I started working with 3D printers and have slowly found ways to utilize it in my business, both to minimize e-waste and save my customers money. More than just novelties like the examples we keep up front, I've designed hooks and holders for tools, feet for computers out of flexible filament, hard drive to SSD brackets we use all the time, and even custom parts to fix things that are otherwise unfixable. The tutorial today will be about one of these unfixable parts, a particular hinge issue we fixed with 3D printed replacement posts. I've been doing it for a couple years now, so I'm confident enough in its strength and viability to share it. I'm not going to show the teardown process because this should work on any laptop that uses brass grommets pressed into plastic posts. It's up to you to find a good tutorial for disassembling your particular model. The reason I came up with this repair is that on most newer laptop models, the palm rest is also the motherboard tray, so replacing it is more of a motherboard swap than a simple palm rest or keyboard replacement like in older models. This also means extra parts and labor cost. I offered an entire palm rest replacement or the 3D printed fix, but the 3D printed option is usually about half the cost and she decided to try it. There's not much risk if you're only modifying the part that otherwise needs to be replaced, so you can always just replace it later on. The tools I'll be using today are an electric screwdriver, nylon pry tool, manual screwdriver, flat build pliers, a rotary tool with a flat tipped bit, a toothbrush for cleaning up excess plastic, tweezers, ceramic can help when pressing in the grommets, a soldering iron for pressing the grommets into these posts, a gel super glue, I prefer the Gorilla Glue Gel XL, and some pliers with a razor blade for shortening the posts. If there are any wires in the way, make sure to move them. On this model, the left hinge has a video cable and the right hinge has a wireless cable. Lifting the hinge is the first example of why I use flat build pliers. It allows you to get up underneath it without applying excess pressure to other areas and risking excess damage. Make sure to remove any loose plastic, although some of it may be easier to remove after the next step. Make sure you have a good grip on the grommet and use your screwdriver to unscrew it. Another example of the flat build pliers benefit is being able to fit between the top grommet and the hinge. Using the flat bit on the Dremel removed the original post and some of the surrounding plastic. It looks jittery because I'm applying a decent amount of sideways pressure. In my experience, getting the bit to heat up makes things go a lot smoother and applying pressure gets it there faster. After you remove most of the material, very carefully flatten the bottom surface, but make sure not to go any deeper than the original. I suggest you clean off the excess plastic over a trash can after this step. With the soldering iron at around 160 to 180 degrees Celsius, press the grommets from the original post into the 3D printed ones. They're normally tapered, so make sure to put them with the smaller end down. I've designed these posts to bottom out and allow the screw to thread into the plastic as well for some extra strength, so unless you have the soldering iron too hot or pressed too hard, it should just stop. If you've lost the original grommets, they are available online, but make sure you get the right size for your laptop. This can be tricky, but some research and a pair of calipers will usually get the job done. My preferred technique to get everything lined up is to screw the new posts onto the hinge and fold it down into place. So make sure you're putting the screw and the grommet into the appropriate hole to line up with the space you flattened and tighten them together. I printed these on a raft so that they wouldn't be smooth on the bottom and give the glue some extra surface area to grab onto. Now put just enough glue down into the flat spots to grab the posts, but without encroaching into the screw hole or the surrounding areas too much. If you can't just fold the hinge down, lift the palm rest a bit so it can clear the frame. There will usually be an alignment peg or a surviving post to help line everything up. If you feel like there's too much of a gap or if things aren't making good contact, you can carefully wedge something between the screen and the palm rest. Excess pressure can risk cracking the screen, so make sure you aren't flexing anything, just making good contact. Spinning the screw in place will also spin the post and help spread the glue more evenly. Although I'm very apprehensive about clamping a laptop, these clamps are very weak when they're barely open, so I decided to use them since the right hinge just wasn't sitting flush. 3D printing is amazing for being able to make things that otherwise might not exist, but the layer lines are often a major failure point. So after the initial glue is cured, I normally go back and let some thinner glue run down the sides. This will both help the layers adhere and will pull at the bottom to make a stronger bond to the palm rest itself. If you're working on a higher end laptop, or if you just want to make sure that the fume residue doesn't stain the casing, you can mask off the surrounding areas. You also need to be extra careful not to get any glue into the screw holes. Using a hole punch on some painter's tape will create a perfect mask for the top of the post. After I got everything back together and did a test fit, the power button wasn't working. I found that the grommet under the motherboard was necessary to keep it against the facade button on top and wasn't close enough to hit the actual button on the motherboard. I designed these posts specifically for the HP 15s that come in all the time, but you can pretty easily shorten these posts by a couple millimeters if you need to. The layer lines actually make this pretty easy, just make sure that you cut straight down. After a test fit, I put on some glue and lined it up. Pressing on the board should let it grip enough to tighten the screw for alignment. Putting the other screws in is a good idea, but remember that if you put an exterior screw all the way in without the exterior on, you may poke through the palm rest. Sadly, because the exterior power button was right next to the grommet, the glue ended up fusing it to the surrounding plastic and I had to Dremel that apart. I'm leaving this here to show that sometimes things don't go as planned, but it doesn't mean you can't make it work. Now that everything is working properly and has had ample time to cure, we need to test the hinges themselves. I'm not going too aggressively, but I want to make sure that everyday use isn't going to shatter anything. Well, that's it. A repair that would have required a part ranging from $60 to $200 and normally 1.5 to 2 hours of labor, done for 1 hour and a few printed parts. I know it's counterproductive as a business owner to offer these types of less expensive repairs, but this industry isn't what it used to be. Parts aren't always available, and even when they are, there's no telling how much they'll cost. So instead of relying on third-party used parts sellers in an industry that's becoming more disposable by the year, I'm going to do what I can to keep them running as long as possible with the tools at my disposal. I hope this was educational for others in my industry, or even just entertaining for those frustrated by how easily things break these days. Either way, thank you for watching. Again, this is David with DNA Computer Works, and we hope to help you soon.